Today we want to talk about the strongest and most mysterious star that exists in the universe, the magnetar. A star whose magnetic field is 100 trillion times stronger than Earth's magnetic field. But assuming this, indeed, I want to take you to a peculiar place. What would happen to you if you fell into the heart of one of these cosmic monsters? Wait, let me clarify something right from the start. This experience is scarier than any nightmare you've ever had. Magnetars not only have the incredibly strongest magnetic fields in the universe, but they also, in fact, have the power to destroy you atom by atom. Stay with me until the end of this video because we're going to talk about the nightmare of magnetic fields. We'll discuss how these giant stars can turn your body to dust and the theories suggesting that magnetars might have even destroyed life on Earth in the past. So make sure to like the video and tell us in the comments how dangerous you think these cosmic monsters are. Before we dive into magnetars, we need to have some additional and comprehensive background on the cosmos first. The planet Jupiter is indeed a very massive giant in our solar system. But if we go inside Jupiter, nothing good happens at all. Because it's a place where a person could turn into a burnt potato. However, despite its vastness, Jupiter is not considered anything special in the galaxy. It's indeed true that Jupiter is an electromagnetic giant in the solar system, but compared to a magnetar, it's like a fridge magnet. This planet isn't even big enough to become a brown dwarf. Of course, brown dwarfs themselves aren't large enough to become stars, and only a limited number of stars are big enough that at the end of their life, they can turn into a neutron star, or crazier than that, into a black hole, pulsar, quasar, or magnetar. Are these stars or the names of villainous characters? Although their names differ, these are almost different versions of a strange concept. But let's start with black holes. The only black hole we have a picture of is a black hole named 87, which is called Pohar. Although this black hole is a true giant and weighs several billion times the mass of the Sun, Pohar is just an ordinary case among black holes. Black holes attract the gas, dust, and other materials around them, which heats up due to rotation and friction, thereby producing infrared light that our telescopes can capture. Some supermassive black holes emit extremely powerful and intense energy and other forms of radiation. If those rays are bright enough, we say that the black hole is a quasar. Now, if that quasar appears very bright, it is called a blazar. In summary, quasars are essentially extremely bright black holes, and blazars are quasars from which we see even more brightness. So their names differ because they appear different, but essentially they are the same. Similarly, neutron stars, pulsars, and magnetars are almost the same thing. Stars that have collapsed, but not enough to become black holes. But how does a star collapse? Stars are essentially the site of a battle between nuclear fusion, which sends energy outward, and gravity, which tries to pull everything inward. But when the fusion fuel, which is usually hydrogen, runs out, gravity wins and the star collapses. Whatever form a star takes after a supernova, it is in some way very extreme. In supernovas, the collapsed stars say, "I make my own rules of physics." If a supernova has a mass more than 3 times that of the Sun, it usually becomes a black hole. The smallest black hole discovered so far is 3 and 3 times the mass of the Sun. But we still don't know exactly how small a black hole can be. Stars with less mass typically produce white dwarfs, but neutron stars are much smaller in size. Usually when we talk about space-related things, we talk about light years and millions of kilometers or miles. But not here. Neutron stars aren't even the size of New York City, but their mass is extremely high. Neutron stars, like other stars, have layers. Their outermost layer is called the atmosphere. This atmosphere is only 10 to 15 inches thick, which is about 25 to nearly 40 centimeters. It is usually composed of light elements like hydrogen and helium. But we know of a neutron star whose atmosphere is made of carbon. Carbon that is so compressed that its density is like that of a diamond. In short, beneath the atmosphere is a solid crust of ionized elements and subatomic particles. But below that, things get really strange. Some models suggest that these layers might be flat, while others say they might resemble noodles or pasta. In any case, these materials are among the hardest and strongest things in the universe. But in the universe, everything rotates. Nothing remains stationary. Neutron stars also usually spin very quickly. The rapid rotation of neutron stars generates an incredibly strong magnetic field. The magnetic field is measured in a unit called Gauss. For example, the Earth's magnetic field on its surface is about half a Gauss. But the magnetic field of a neutron star is on the order of trillions of Gauss. However, some neutron stars have a magnetic field that reaches up to a quadrillion Gauss, which is a 1 followed by 15 zeros. These cosmic monsters are often known as magnetars. Now let's assume, what would happen if you were to fall towards a magnetar? First of all, the gravitational force of a magnetar is so strong that it accelerates you to 2/3 the speed of light in less than a second. This means approximately 200,000 kilometers per second. This brutal acceleration causes your body to stretch, so to speak, just like a piece of dough being pulled by hand. This process is known in physics as spaghettification. It means you literally become spaghetti-shaped or turn into a human spaghetti. From the perspective of someone watching you, this event only takes a few seconds. But from your own perspective, due to time dilation, it probably takes 10 to 15 seconds. Well, let's be completely honest. No one comes out of this alive. But let's assume a miracle happens and we survive. Well, then what? The magnetar's magnetic field tears you apart atom by atom. This means that before your body reaches the surface of the star, your atoms are severely deformed due to this magnetic field. The atoms in your body are made up of protons, neutrons, and electrons, but this magnetic field is so strong that it separates these components. The electrons are separated from the protons, and as a result, your body turns into a kind of chaotic plasma. In other words, this magnetic field essentially breaks atomic bonds and turns your body into a mushy substance before gravity can do anything. Now let's move on to another interesting part. What effect does this magnetism have on your nervous system? In these conditions, your nervous system shuts down. The ion channels that send nerve signals to your brain no longer operate properly. This essentially means you can't move, breathe, or even feel pain at all. You don't feel anything at all. Your heart stops. Involuntary muscles cease to function and your brain shuts down. You might even experience some strange hallucinations before everything shuts down. Now you might think this is the end, but it's not. The high speed of your fall when you hit the surface of the magnetar creates an explosion more powerful than all the nuclear weapons on Earth combined. This impact releases so much energy that its brief flash can be seen across the universe. But one question remains. Where does a magnetar inherit its magnetic field from? There are various theories, but studying these phenomena is very challenging, because so far, only 30 magnetars have been discovered. Scientists believe that there are between 1 million to 100 million magnetars in the Milky Way galaxy. However, many of them have not yet been discovered. The closest magnetar to us is about 9,000 light years away. But because that distance is so far, the energy is effectively dispersed and weakened in space. We were saying where this magnetar got its magnetic field from. The prevailing theory says that a magnetar inherits its magnetic field from the star it collapsed from. So this unusual neutron star is strong itself because it originated from a very strong star. But some critics say that if the original star really had such a strong magnetic field, it couldn't have collapsed into a neutron star at all. Another theory suggests that this magnetic field is amplified, undying at the moment of collapse. This process is called a magnetic dynamo. However, another interesting theory related to neutron stars and magnetars also pertains to the collapse of magnetars. When the surface of a magnetar cracks, intense gamma rays are produced and a phenomenon occurs known as a starquake. Scientists believe that one of the major extinctions in Earth's history, the Ordovician extinction, which occurred approximately about 450 million years ago and led to the extinction of 60% of marine species in total, may have been caused by a gamma ray burst or GRB resulting from a magnetar. Scientists have calculated that the probability of a gamma ray burst causing an extinction in the past 500 million years is about 50%. If we extend this time frame to 5 billion years, this probability reaches 90%. With this in mind, it is possible that one of these gamma ray bursts could have wiped out an entire branch of life on Earth. Now imagine how different life on Earth would be today if those extinctions had not occurred. If I were to summarize, I would say that magnetars are the true monsters of the cosmos. Stars that can literally destroy you atom by atom and create explosions that shake the galaxy. They are harmless from a distance, but the possibility that one of these cosmic monsters could accidentally harm life on a planet like Earth always exists. However, this fair can encourage us to learn more about the cosmos and explore it further. Remember that you told us the topic of this video, so we are looking forward to your comments.